Welcome to Lesson 2 in the Mr. Circuit Lab 3. In this lesson, you will learn about the NOT. The NOT digital logic gate is also known as a logical inverter. Whatever input the NOT gate receives, a high or a low, the output always will be the opposite. That is to say, if we put a low on the input, we will get a high on the output, etc. The rule for the NOT gate is stated as follows. The output is false only if the input is true. Here is the symbol for the NOT logic gate. It looks similar to the yes gate, except that it has a small circle on the tip of the arrow. This circle means it inverts the output of the yes gate. You will find that all the logic gate symbols follow this pattern. Here is the truth table for a NOT digital logic gate. You will notice that only when the input is a 0 will the output be a 1. Building an electronic NOT logic gate. Here is a schematic diagram for an electronic NOT logic gate circuit. In this Mr. Circuit Digital Logic Gate Lab, as part of your training, you will construct this circuit on a solderless breadboard. Let me explain the circuit. You will notice that this circuit is similar to the yes gate as it has one transistor, one LED, two resistors, a 9-volt battery, and a normally open push-button switch. As in all digital logic gate circuits, when the LED is lit up, it means that there's a true on the output. Again, let's talk about the transistor. Remember that when the transistor is forward biased, it means that it has the correct voltages on its pins to allow electron current to flow through it. In this NOT gate circuit, the engineer designed it so that as soon as you connect the 9-volt battery, the LED lights up. This is because there is a path for the current from the negative of the battery through the LED and then through R2 back to the positive of the battery. But when you press switch S1, the transistor is forward biased, which causes all the current to flow through the transistor, then through the resistor R2, and then to the positive of the battery. No current is left over for the LED, so the LED does not light up. In electronics, we say that this transistor is essentially a short circuit because it is forward biased. When you release switch S1, putting a low on the input, the LED lights up, showing a high on the output. So as you can see from this explanation, this circuit works like a NOT digital logic gate. When the input is false, no voltage on the input to the transistor, then the output is true. The LED lights up. Now that you understand how the electronic circuit for a NOT logic gate works, you're ready to build one as part of your training, following the step-by-step instructions in the Lesson 2 booklet in the Mr. Circuit Lab 3. Now that we have taught you the theory, building the circuit is the application. The world needs lots of people who know, understand, and can work with digital logic gates. Continue with the rest of the lessons in this lab so you can earn your certificate of electronics training that you can display and add to your resume. If you need to buy the lab, you can purchase it at www.mrcircuittechnology.com. We hope you are enjoying this lab and will want to learn more electronics. Thank you from all of us at the Mr. Circuit Technology Company.